Hi everyone. Today I want to show you how to work with equations of lines. And we've actually been doing this already quite a bit this year. What we're going to do today is learn what is called point slope form, which is this one down here on the right. We've been using slope intercept form, we just haven't called it that. And so what I did on your handout here is I actually wrote a more generic version of slope intercept form. And so what I'm highlighting here is kind of the format we've been using. What I want you to see is how that connects to a lot of the stuff we do in plain mathematics. As you've heard me say, these lovely mathematicians that we work with all the time are lazy. And so a mathematician doesn't want to write all this out. So what do? Well, they look at a graph and they try to basically create a variable to represent a word. Okay, so if you look at this graph, this isn't on your paper, but you can sketch it on there. The y-axis is our dependent axis. And so for our dependent axis, instead of writing the word dependent, we'll just write y, the letter y. Slope, we've actually seen this before, and slope uses the lowercase letter m. On our image here, the independent axis is the x-axis, and the y-intercept, mathematicians use the letter b to represent that, and I don't know for sure why. I don't think anybody really knows why, but I think it's because you can think of that as the beginning amount or the beginning value. Okay, so what I'll have you do is I'm going to have you fill out this information on your note sheet, and then we're going to actually use this here in just a few minutes. Okay, so slope intercept form, again, you've seen this before. So what I want you to do is take this information in red and then just copy it down. So y equals mx plus b, that is the exact same thing as this highlighted yellow statement here. Notice the y is by itself, and whenever we know the slope and an initial amount or something that we're beginning with, this is a really good form to use. And so a lot of times, like with your position time graphs, we knew the initial position and we know the velocity, and so this was a great situation to use y equals mx plus b. Okay. It's also a good time to use this form like with our labs, because with the labs you'd work on, we don't need a precise y-intercept. We just need an approximate value. So a lot of times we'll just say, oh, well, our line looks something like that, and the y-intercept falls somewhere between 1 and 2, so we might just approximate that and say 1.5. Well, today I'm going to teach you how to get that precise value to see exactly where that crosses through your y-axis. As long as we have some other information, we can figure that out. Okay, so if you look over at the right, be careful when you copy this formula down. A lot of students think that the ones are exponents. Like, in other words, we're raising it to a power. But that's not the case. This 1 is a subscript, and I think of subscripts kind of like last names. So like y1 and x1 just represent some ordered pair on the graph. So off to the side, let's just write that. Let's put that x1 comma y1. And I'll make those subscripts here. X1 and Y1 just represent some point on the graph. So like maybe in your lab, that represents some data point. Okay, on the line. It has to be on the line of best fit. It doesn't just represent a random point. Our m, as we already know, m is our slope. Oh, sorry if you hear my dog coming this way. That's okay. Okay, so we have our setup here. Again, keep this boxed off. This is the guy we're going to be working with today. All right, so when is this good to use? Well, we can use point slope anytime we have two ordered pairs, or if we know one ordered pair and the slope associated with the graph. So either of these situations is good for point slope form. Generally, we want to get y by itself, and again, it's good to use when we want an exact y value. All right, pause right now, and I'll end the video. Actually, I'll end this, and then if you have any questions, you can ask me before we move on to a couple examples.